right, let's look at question 6. Question 6.1. In the diagram, the graph of f of x is equals to tan bx is drawn for the interval x less or equals to 135 degrees but greater or equals to minus 90 degrees. And we have a diagram here for the graph of f of x is equals to tan bx. Question 6.1.1, we have to determine the value of b. Alright, now before we get to 6.1.1, let's first draw the basic graph of y is equals to tan x for the interval 0 degrees to 360 degrees. Now it is best to know the graphs of tangent, sine and cosine graphs by heart, what we call the mother functions, because from those mother functions, whatever type of a function that you will be given with some changes, you'll be able to just relate it to the mother function and just ask yourself what changed in this function from the mother function. Right, let's start with the graph of y is equals to tan x for the interval 0 degrees to 360 degrees. Okay, let's have the y-axis, the x-axis 1, minus 1, 45, 90, 135, 135, yes, 180, 225, 270, 270, 315, 360 degrees. 1, 2, 3, 4, 5, 6, 7, 8. Alright. Now asymptotes, x is equals to 90 degrees, x is equals to 270 degrees. 0, this will be the first x-intercept as well as the y-intercept. Then the critical point 45 degrees and 1. And then we have the graph x-intercept at 180 degrees, critical point 225 and 1, and then we have our graph, the other critical point 135 degrees and minus 1, and we have the graph, the other critical point 315 and minus 1, and then the x-intercept 360 degrees and 0, and then we have this part of the graph. So now this is the graph of y is equals to tan x, the basic graph of y is equals to tan x in the interval 0 degrees to 360 degrees. Alright, now looking at the mother function or the mother graph and the graph that we are given, the graph of f of x, let's only focus on the asymptotes. Let us only focus on the asymptotes. We know that our asymptotes here from the mother graph 90 degrees to 70 degrees, but on the graph of f of x asymptote on the positive x-axis 45 degrees, 135 degrees. So what is the difference there? The difference is that the position of the asymptote from the mother graph to the graph of f of x, it is halved. So now what will be the value of b? F of x is equals to tan bx. The position of b there, the question is, how does b affect the critical point? Number one, B will affect the x values of the critical point. How? By division. Therefore, it means what? Whatever the value of B will be from the mother function to the graph of f of x, we are going to divide the values of x by b to get the new values of x for the graph of f of x. Therefore, it means what? We divide, focusing on the asymptotes. Let's only look at what? 90 degrees. 90 degrees divided by b will give us 45 degrees. What should be the value of b? It's very clear that the value of b should be equals to 2. Or you can just simply what? Solve the equation. 90 over b is equals to 45. Then you get that 90 divided by 45 is equals to 2. So b will be equals to 2. Now 6.1.2, determine the values of x in the interval 0 degrees to 135 degrees. Meaning on the right of the y-axis. We only focus on the right of the y-axis, but where? For which f of x is less or equals to minus 1. Therefore, we are only going to be concentrating where f of x is equals to minus 1 at this point and below. F of x less or equals to minus 1, meaning where f of x is equals to minus 1 or is less than minus 1. So this is where we have highlighted here in the graph, where our graph of f of x is equals to minus 1 or less than minus 1. Now the question is, what is the value of x where y is minus 1? We are now what the value of x at this point. Now again we go back to what? To the mother graph. When you look at the mother graph, where we are having where we'll be having what? The value of x at this point. From the mother graph, this is where we had what? 135 degrees. If you compare the mother graph and the graph of f of x, it was what? 135 degrees. But what happened? We know that from the mother graph to get to the graph of f of x, what do? We divide the values of x by 2. So now we say 135 divided by 2. 135 divided by 2 gives us 67.5. Therefore, now our solution, the values of x where f of x will be less or equals to minus 1 in the interval 0 to 135 degrees. It will be where? It will be where x is less than 67.5 but greater than 45 degrees. Clearly there 45 degrees. But now we are having what? Less or equals, not just less than. So the question is, are we all going to include 45 degrees and 67.5? Let's check. At 67.5, what will be the value of y? The value of y will be what? Minus 1. And we had what? F of x less or equals to minus 1. Therefore, minus 1 is included. Therefore, 67.5 will also be included. Now, at 45 degrees, what is happening at 45 degrees? X is equals to 45 degrees is an asymptote. And we are not going to include what? The asymptote, as we know that the graph is not going to touch the asymptote. So our solution will be x is less or equals to 67.5 degrees but greater than 45 degrees. And then now 6.1.3, the graph h is defined as h of x is equals to tan b into x plus 55 degrees. Write down the equations of the asymptotes of h in the interval minus 90 degrees to 135 degrees included. Firstly, the graph of h in relation to the graph of f, what happened? You can see that h is f shifted 55 degrees to the left. Now a shift to the left, the question is, in terms of the critical points, does it affect the x or the y values? It affects the what? The x values. So h is actually what? The graph of f shifted 55 degrees to the left. So now it means what? The new equations of the asymptotes, we are simply going to take what? The equations of asymptotes of f, and we are going to shift them 55 degrees to the left. Let's start with 135 degrees. Asymptote x is equals to 135 degrees. Shift it 55 degrees to the left. 135 minus 55 will be equals to 80. So we are having 80 degrees. Then the other asymptote, 45 degrees. Shift it 55 degrees to the left. 45 minus 55 gives us minus 10 degrees. Then the other asymptote, minus 45 degrees. Shift it to the left. 55 degrees minus 55 gives us minus 100 degrees. But now we are given the interval here, that we need to give the equations of the asymptotes in the interval minus 90 to 135. Therefore, it's clear that minus 100 is not in that interval. Therefore, our solution will be what? Will be where x is equals to minus 10 degrees and where x is equals to 80 degrees. Right now, question 6.2. In the diagram, the graph of g of x is equals to cos of x plus 60 degrees is drawn for the interval minus 150 degrees to 120 degrees. Right, now 6.2.1. On the same system of axes, draw the graph of k of x is equals to minus sine x for the interval minus 150 to 120 degrees. Show all the intercepts with the axis, x and y intercept, as well as the coordinates of the turning points and end points of the graph. Now, let's start first by drawing the basic graph of y is equals to sine x. Remember, we said it's very important that you know the mother graphs of sine, cosine, and tangent graphs by heart. So for this one, we are going to need the mother graph of sine. So let's draw the mother graph for sine. Y-axis, x-axis, 1 half minus half minus 1 and 0. So we'll have our intervals 90, 180, 270, 360. Minus 90, minus 180, minus 270, minus 360. Alright, so turning point, x-intercept, turning point, x-intercept. Here we are. Should be somewhere here. Right, and then turning point, x-intercept, turning point, x-intercept. Here we are, x-intercept, turning point, x-intercept. Alright, now we need to draw the graph of minus sine x. So the critical points, x, y intercept 0 and 0, turning point 90 minus 1, the x-intercepts and other turning points. But now, because on the graph of g of x, we also have what? Half. So at this point, what will be the value of x? X here will be 30 degrees. 0 plus 30, and at this point here, x will be, at this point here, x will be 180 minus 30, will be 150 degrees. And at this point here, where y is minus half, x will be 210 degrees. And at this point where y is half, again x will be 360 minus 30, 330. At this point we say 210. And then on the negative x-axis, minus 360 plus 30, half here will be minus 330 at this point. At this point where y is half, we'll have minus 180 minus 30 minus 210 degrees. And then at this point we have minus 150. At this point we'll be having minus 30. This will be minus 30 degrees there. Now we need to draw the graph of minus sine x. So minus sine x, how is it different from y is equals to sine x? It is that k of x is the mother graph shifted along the x-axis. So in terms of the critical values, which values are affected, x or y? It will be the y values. How? By multiplication. We multiply the y values of the critical points by minus 1, in this case for k of x. So let us also on our diagram here, we are having 0, 30, 60 degrees, 90 degrees, 120. Here we have minus 30 degrees, minus 60, minus 30, minus 90, minus 30, minus 120, minus 120 here. Alright, so now we sketch. Let's start with what? With 0. 0 and 0, 0 times minus 1 is 0. So we are going to have our y-intercept, x-intercept there. Then this point, 30 and half will be 30 and minus half. We'll have a point here, 30 minus half. And then the point 90 and 1 will become 90 and minus 1. Remember, we are multiplying the y values by minus 1. 90 and minus 1 will be at this point. And then the point we're now going to stop at what? At 120. So we don't have 120 here on our graph. It's not a problem. We just have to find what? Sine of 120. What will be sine of 120? Use your calculator. Make sure that it is in degree mode. You should get root 3 over 2 in a decimal, 0.866 rounded off to 2 decimal places. Therefore, it will be just what? On the right, somewhere at this point. where we are having what, 120 degrees. Therefore 120 and minus 0,866. For k of x it will be 120 and minus 0,866. So this point it will be just above minus 1, just above minus 1. Then let us join the points. Let us join the points. Let us join the points. So here we are having the point 120 degrees and root 3 over negative root 3 over 2. And this is our turning point, 90 degrees and minus 1. And clearly here our x-intercept or y-intercept is 0 and 0. Alright, now on the left, on the negative x-axis, we had a point minus 30 and minus half. Minus half times negative 1, we get positive half. We get a point here. Then we had a turning point minus 90 and minus 1. Minus 1 times minus 1. We are going to get positive 1. It will be a point there. And we also have a point minus 150 and negative half. It will be a point here which is negative half times 1, positive half. Will be a point there. Then let us join the points. Let us join the points. And then this point, the end point will be minus 150 degrees and positive 1 over 2. The turning point minus 90 degrees and 1. So this will be the graph of, this will be the graph of k of x is equals to minus 1 over, k of x is equals to minus sine x. So this will be the answer for question 6.2.1, where we have drawn the graph of k of x, clearly showing the x, y intercept, end points, as well as the turning points. Alright, now question 6.2.2, determine the minimum value of h of x is equals to cos of x plus 60 degrees minus 3. G of x is equals to cos of x plus 60 degrees. Now what is the difference between h and g? Is that h is g shifted 3 units down. So the question is, what is the minimum value of g of x? It's clear here from the graph that the minimum value of g of x is minus 1. Therefore, from minus 1, we are going to go 3 units downwards. Therefore, minimum value will be equals to minus 1 minus 3 will be equals to minus 4. And 6.2.3, solve the equation cos of x plus 60 degrees plus sine x equals to 0 for the interval minus 150 degrees to 120 degrees included. So now looking at our equation, we can simplify the equation to cos of x plus 60 degrees is equals to minus sine x. So what are we having? Cos of x plus 60 degrees is g of x minus sine x is k of x. So we actually have to what? We actually have to find the x values where the graph of g intersects with the graph of g. The graph of g intersect with the graph of k. We need to find those x values, which will be where at this point where the two graphs intersect. So now we are going to solve this using what? Trigonometric equations, starting first by determining the general solutions and so forth. So we are going to have cos of x plus 60 degrees is equals to, we'll simplify, minus sine x as cos of 90 degrees plus x, applying the reduction formula. So now finding the general solution, our ratio is cosine, and the approach that we'll be taking, the approach or the method e.g., if we are dealing with the ratio cosine, let's say cos of x is equals to a can be any real number, a being any real number, then what will be x will be equals to plus or minus cos inverse of a plus k times 360 degrees. Therefore this means x will be positive cos inverse of a plus k times 360 degrees, or x will be equals to minus cos inverse of a plus k times 360 degrees. If a is positive, you substitute it as positive. If it is negative, we substitute it as negative, meaning we are using the graphical approach and not the approach of first finding the angle of reference. So applying the method here, we'll be having x plus 60 degrees is equals to plus or minus cos inverse of cos of 90 degrees plus x will just be 90 degrees plus x plus k times 360 degrees, meaning x plus 60 degrees will be equals to, first positive 90 degrees plus x plus k times 360 degrees, or x plus 60 degrees will be equals to, now negative times 90 minus 90 degrees, negative times x minus x plus k times 360 degrees. And then on the left hand side, trying to solve the equation, you will see that x minus x will be 0, meaning we'll just be having a number will be 0. Therefore 60 degrees is equals to 90 degrees plus k times 360 degrees. X is gone. Therefore this part of the general solution, there will be no solution here, no solution. Or now on this part of the general solution, x plus x will be equals to 2x equals to minus 90 minus 60 minus 150 degrees plus k times 360 degrees, and then divide both sides by 2. X is equals to minus 75 degrees plus k times 180 degrees. Don't forget k is an element of integers. So now we need to find the values of x by substituting different values of k. Remember, we already know that those two values, those x values, it should only be what? 2. The one that is just to the right of minus 90, and then the other one is just to the right of 90 degrees. So let's first substitute k is equals to 0. When k is equals to 0, what will be x? X will be equals to minus 75 degrees. And then when k is equals to 1, what will be equals to x minus 75 plus 180 will give us 105 degrees. and then any other values of k that you are going to substitute there, they are going to fall outside the interval. But we are given the interval from minus 150 to 120 degrees. So the only solutions will be what? Minus 75 and 105 or 105. So let us now write the solutions properly. Therefore, this is the values of x will be x is equals to minus 75 degrees, or x will be equals to 105 degrees. And then lastly, question 6.2.4, determine the values of x for the interval minus 150 to 120 for which cos of x plus 60 degrees plus sine of x is greater than 0. Then we can simplify this inequality to cos of x plus 60 degrees is greater than minus sine x. Meaning, what is cos of x plus 60 degrees? We know it is g of x. What is minus sine x? We know it is k of x. Therefore, what do we want? We want where g of x is greater than minus sine x. Therefore, it means what? Or where g of x is greater than k of x. Therefore, we want where the graph of g is above the graph of k. So here on our graphs, we can see that happens where? That happens between the points of intersection, where x is minus 75 degrees, between minus 75 degrees and 105 degrees. We've already calculated the x values where the two graphs intersect. So g is above k between minus 75 degrees and 105 degrees. Therefore, our solution will be where x is less than 105 degrees but greater than minus 75 degrees.